This lecture is all about decoders. Now, you've already seen decoders in this class before because you've seen a truth table. And another word for a truth table could be a lookup table, because all decoders can be written as lookup tables. Now, we're going to discuss a classification of decoders between generic decoders and standard decoders. And generic decoders are just anything that can be stuck into a lookup table. So if you recall from the previous lecture, what we were designing here, if we had completed this from binary coded decimal from 0 to 9 and then having all these different 7-segment displays, this would be a decoder from BCD to 7-segment display, which is what you would have implemented in lab. Now, this is also a reminder that the best way to implement decoders is using one of the constructs of VHDL, such as the selective signal assignment or behavioral model. So let's just review that for a moment. Let's take this as our generic decoder. It's just a truth table that's showing relationships between an input and an output. So we can write this that when LMN is 001, F3 is going to get a 1, and when it's 110, it's also going to get a 1, and when it's 111, it's also going to get a 1. So we could have used, as we did in the very beginning, a data flow model, take this into a K-map, figure out the circuit equation, and write that out, or we can use the different modeling techniques with these different constructs. So, for example, like we've done before, this is using a selective signal assignment. So we've declared our entity of LMN as the inputs, F3 is the output, and we declared an intermediate signal, which is a 3-bit vector, which is going to combine LM and N. So as you can see here, begin, the intermediate signal is going to get L concatenated with M concatenated with N. And then with this signal, sig, select F3 to be 1 when the conditions of LMN, which we already looked at in the table, will give us a 1 and 0 when others. So this is a really quick way of implementing a generic decoder. Another option would be to use this sort of statement. Again, you could find all these constructs in the VHDL cheat sheet. Here instead we have LMN is already a 3-bit input vector, so we don't need to create a temporary signal. So with LMN, select F3 gets 1, blah blah blah. And we can go for now the conditional signal assignment. I'm not spending a lot of time on these because we already talked about them. So again, LMN again is just 1 bit here, so we grouped them to make it easier to type out. F3 gets 1 when LMN is this or this or this, else 0. These are all great solutions for quickly implementing generic decoders. And again, we have the behavioral model option where we use the process statement. Same idea, we group the signals, but we put it in a process. The process has a sensitivity list. These are your inputs that tell you when the inputs change, you want your process to be evaluated. So if anything changes in LMN, we want to re-evaluate our process to see what new output might be produced. So in this case, if LMN is 001 or 011 or 0 or 111, then the output's going to get 1, else the output's going to get 0. Every if has an end if, so there's our end if and an end process. Same exact solution, just a different way of writing it in VHDL. And then there's the case statement that we can use. Again, grouping the signal, case, LMN. When the case is 001, or this bar means or 110 or 111, then F3 gets 1. When others, F3 gets 0. Okay, so now we can look at something called advanced generic decoders, and this is just looking at some larger blocks where we have inputs A, B, C, and D and outputs T1, T2, T3. And we can just group these all together. This can be a 4-bit input, this can be a 3-bit output. And we can use the same constructs again, noticing though that we can have a when others clause get 0 for all these different input conditions, because you can see the outputs for T1, T2, T3 are all zeros here. So this is really easily seen looking at these two approaches with ABCD. So that's our 4-bit input signal. Select the output T1, 2, 3, which is the 3-bit output signal. So it gets its different values, which you're getting straight from the table when the input is a certain condition. So these are just coming straight out of the table, and then you can see you've listed all the ones that give different outputs and then 0 when others. You can do the same exact thing using a process statement. Your input goes in the sensitivity list, and there you go. When the input is this, T1, 2, 3 is going to get that. And you list it all the way down till your when others clause, and you're done. And there's just another example of that. This example is actually worthy to mention. This one here, as you can see, is the same exact circuit, but it has this chip enable pin. And what this chip enable pin is doing is saying, only give me the output T1, 2, 3 when the chip enable pin is a 1, otherwise don't give me anything. So whenever you have a control signal like this, the easiest way to model your entire circuit is with a behavioral model, because you have the ability to use if and else statements. And it's really easy to say, if CE is 1, give me this output, else don't give it to me. So I would only use the behavioral model when you have those type of if and else kind of conditions. So here again is our architecture that describes the input ABCD, which is a 4-bit vector, CE, which is a input, just a single bit input, T1, 2, 3, which is an output. And then we have our process. Again, I said we want to use a behavioral model when we have these if type conditions. So we're going to put ABCD and CE both in the sensitivity list, because we want the process to be re-evaluated when either one of these changes. So here we have if CE is 1, then we look at the case ABCD, which is the input. When it's 0, 0, 1, T1, 2, 3 is going to get this, etc., all the way down to the when others clause. So this covers the case when the chip is enabled. Else, which is when the chip is not enabled, so when CE equals 0, T1, 2, 3 is going to get all zeros. So, like I said again, that we like using the behavioral model when we have these if-else type of conditions. Okay, so that brings us to the topic of standard decoders, and I will go ahead and put that in a next clip.